Hey, welcome to this Programming for Cultural Heritage demo video. Today we're going to try to play around with GPT-2 and trying to get it to generate some text based on the training model. So we would want to do this because there's some interest in working with generative text procedures and kind of like generating new text based on existing corpuses. One kind of recent open kind of source model that was released is the GPT model that was released by the OpenAI Institute. And so basically, this is like a machine learning a predictive model that basically it was trained on a huge corpus of text, and then it can kind of predict what word would come next in a sequence of words. So giving it kind of like a more fine-tuned training model, it can try to predict what word would come next and kind of generate some new text. And so the current one version of GPT that you can download is GPT-2. And so we're going to try to play around with that. There is a GPT-3, but it seems like that's just an API that's available to use via the OpenAI institution. So you can kind of request the API key and then try to work with their API. But you can actually download the GPT-2 model and use it locally on your computer. So we're going to try that. And so, you could try to do this from scratch, but we're going to try to use a Python module that already exists to try to start working with this uh, generative text model. So I came across this model or this module called GPT-2 Simple. And basically, it's like a little Python module that you install that installs everything you need to get started with GPT. And so I haven't done this yet, so we're going to try to go through this together and see if we can get it working and, all the pitfalls and problems that we usually will run into. So the first thing we want to do is install it, right? And so it gives us a install command here, pip3 install GPT-2 simple. So let's go to our um, terminal and we're going to try running that. So this, it comes packaged with everything you need and all the additional um, modules that this module depends on. And so it just kind of, installs all those things that if it isn't already there, like for example, it installed a specific version of NumPy that I didn't have installed. So it's setting all that up. All right, so we didn't get any errors, so it looked like it installed. So if we go back to the instructions, it says we need to also install TensorFlow. And so if you see here, it also says TensorFlow 2.0 is not currently supported after the package will throw assertion and floated. So TensorFlow 1.14 and 1.15 is recommended for this module. All right, so I don't believe I have TensorFlow installed at all. So I will install TensorFlow via the pip module install, but we're going to tie it to a specific version. So we're going to say pip3 install TensorFlow, and we can say what version we want to install. And we're going to install 1.15 because that was what the instructions said to use. 1.14 or 1.15 is recommended. So let's see if this works. All right, could not find that version. All right, so to get started with this, we need to install TensorFlow, which is kind of, from my experience so far, is very kind of difficult to get the versions matched up because it only supports a certain range of versions, and then we want a specific version of TensorFlow, and so we have to be able to run a specific version of Python and a very specific version of TensorFlow. So in order to do this, we're going to install a Python environment manager. And so this basically allows you to switch versions between Python. So you can go from running Python 3.5 to 3.9 and back again. Even back down to the 2.7 versions as well. So the first thing we need to do is install this manager, and there's a number of managers. The one we're going to use though is basically one that is very easy to use and very straightforward. And so I'm going to be doing this on Mac, and so I'm not sure if you'll have much success doing this, trying to do this on Windows. You probably just have to install that version of Python manually and maybe remove the old one, depending on how you do it on Windows. So to install this manager on Mac, you need to have Homebrew installed. And so Homebrew is basically a package manager for the Mac operating system. And so if you go to brew.sh, you can install brew by running this command. And then once that's installed, then you can start running installation commands. And so once you have brew installed by running that, it'll take a minute to install. Then you are going to install this PyEnv, so Python Environment Manager. And so once brew is installed, you can simply run brew install PyEnv, and it will install it for you. So let's give it a shot and see what happens. And so while that's installing, we can look at the documentation for the software. And basically, it is a way to, as I mentioned, switch between versions of Python. And so if you want to change pipe versions, so let's see how to use it. If you want to change versions, you just say, PyEnv versions, and it'll show you what versions you have. And then you can set the version global, so whenever you say Python, it will actually run that version. And then you can also, install different versions of it. All right, so now that it is installed, we should be able to run PyEnv, and basically we'll say, okay, here are your options you can run. And so let's look at what versions we have installed. So we don't have any versions yet. So let's start off by, we know that we want to install version 3.5. It was one of the earliest versions that works with TensorFlow that we read. So we can say PyEnv install 3.5. So it does not find that, but here are the options you can install. So let's install 3.5.10, right? So hopefully when this is installed, it will have its own Python version 3.5.10 and its own pip3.5.10. And so that means that we can install whatever we want using that version, and then jump to a different version if we want to use a newer version for different stuff. All right, so now if we type Python in a tab, we should see a number of Pythons available to us. So if we say Python 3 and then ask for the version of that, it's Python 3.9. But now if we say PyEnv versions, it shows us what we have available. And so what we can say is okay, PyEnv use 3.10.5. Or let's see, let's get what we need to. Okay, so we can set the global version of Python to that specific one. So we can say Python global. And so now when we type Python 3 version, it's still version, but if we say Python version, it's that version, so it still didn't work. So Python, we might need to restart this terminal session. All right, so what I did is I closed this terminal session. And if I need to share it again. All right, so I closed the terminal session. So like these kind of things rely on these includes in your user directory to kind of redirect files and overwrite stuff. So basically what I did is I just closed the terminal and opened up a new one. And then if I type Python and hit tab, it shows me the ones I have available. So now I actually have Python 3.5 installed. And so if I ran Python 3.5, it shows me that's the version. So then my current version, I think I set to global. Let's see what it's set to. So, I could go back and change that to the system one. So let's see, PyEnv versions. And so I could say PyEnv global system, and that will just change the global version of Python. So when you type Python 3 and V, it goes back to 9, right? All right, so didn't like that. So I'm going to switch the version back for Python 3 to just be the Python 3.5. So PyEnv global 3.5.10. So now when I do Python 3v, it has Python 3.5.10. All right. All right, so a little confusing there, but basically we installed Homebrew, right? If you haven't installed it yet, we installed Python PyEnv so we could install different versions of Python. We installed a specific version 3.5 of Python, and then we set it to our global. So whenever we type Python 3, that's the version of Python that runs. So you just want to be cognizant that you did that, and you can change it back and switch between versions whenever you want, right? Right, so to return to the task at hand, right, we wanted to install this GPT2 simple module. So let's try this again. And since we now have this like Python manager installed, you will install it under different versions, right? So if you install it under Python 3.5, that's different from installing it under 3.9, right? It's just different kind of directories on your hard drive, right? So they're not the same package. So we're going to try to install TensorFlow through 1.15 again. And hopefully, since now we're running Python 3.5, that's a valid version of TensorFlow to get installed. All right, so now we're going to try to install Python or TensorFlow, and we're going to try to pin it to version 1.15 using this double equal sign. All right, so we successfully installed the GPT-2 simple module and TensorFlow 1.15, which is the set it needed. So let's go back again and try to run the script that they provided. It's just basically a way of testing it, right? So it's going to download this model, this GPT-2 model, and it's going to download this training data from Shakespeare, and it's going to try to generate it on some new information, new fine tune on this model. Let's see if it actually works. So if we actually can run the script and it actually does something, then we know we're on the right route, as opposed to just not even being able to run it, right? So we're going to run that Python 3, and the file is called GPT2 test. All right, so this is interesting. So this version of Python does not support f strings, right? So this is saying this, I don't know what you're doing here. This is not a valid way of doing strings. So what we could do is two things, right? We could install a different version of Python, or we just get rid of the f strings. All right. So I just went into this test, right? And I just got rid of this f string that it was being used as just like a download status. So Oops. So instead of having the F string, I'm just like concatenating strings together instead. So hopefully that is right. Let's try it again. Invalid syntax. And of course you have to put the plus signs in the right place, right? So we don't really know what the script's doing as far as, I mean, right now it's downloading information. So it looks like it's downloading the model. So now I think it's training the model on that Shakespeare data set that it downloaded. Let's look at the code again while it's doing this. Right, so the first part is just downloading the model, the GPT-2 model. Second part is actually just downloading the Shakespeare text, which is just like a Shakespeare plays, and writing it out to file. And then it's creating a new session, and then it's fine tuning based on the data that was downloaded. And the model name is 124, and it's doing 1,000 training steps, and then it's generating a session. All right, so let's see where it's at now. So this, oh, okay. All right, so this generates a model, and it saves it in a folder called checkpoint run. So I'm assuming if you looked in your, wherever you ran the script, you might see a folder. Yeah, so if you're in the, I ran the script in my downloads directory, so it created a folder called checkpoint and run one, and then all the model is in there. And so it's gonna generate the model there once its training is done. So let's see how it's doing on the training. Okay, so this might take a very long time, right? If it has to get to 1,000, then this could take a very long time to fine tune this model to the text provided. So we're gonna let this run, and well, actually, let's cancel it. Yeah, we're gonna stop it, and I'm going to remove the checkpoint directory once it's done. So I'm just going to set the number of iterations for fine tuning much lower so that it doesn't take days to train this to just get some examples running. All right, so it generated some text here. I'm not sure what it was doing, but let's modify the script here to do some not as many steps. Let's just say 100 for this use case here. And let's go back and we'll start it up again and see how long it takes. So that's going to run and we'll come back and see how it's going in a little bit.
All right, so that finished running. We set the script to run about 100 iterations. So that ran, and we can see that here. We set it to 100. I think that took around an hour or more, right? So this is kind of the problem with this machine learning TensorFlow stuff is that if you're using your computer, your CPU computer, it's going to take longer than if you're using a GPU or graphics processing unit. So unfortunately on Mac you can't really use NVIDIA graphics cards, which are more designed or more compatible with this TensorFlow library. So if you're probably going to be stuck using just the CPU to train this, so it could take a very long time, especially if you're going to do something like 1,000 iterations. That would take a very long time. All right, so we can see that it generated some text here in the console output. So it basically, the last thing it does in the script is run this kind of generation command, and it generates some text. And so you can see that this text basically is this is new generative text based on that training Shakespeare data that was provided for the test script, and each one of these lines, it basically tries to mimic the style of the original training document, and generate new text, right? And so if you looked up these sentences in the training document, you would not find them because they're new text, they're generative text, they're not just copying from the existing documents, it's created new stuff. And some of them make sense, right? You know, go up and withal get to us to the court of Naples. It makes sense, right? Um, so the more iterations of training, you probably get better results, more kind of consistent style, and um, more kind of conducive to like the original document text. The more iterations of training you do, but this is pretty good as a test. So what we want to do now though is train it on our own data, right? And so what I did is I went through and I basically just copied a bunch of blog posts I've written. So I copied a bunch of text from my blog posts that I've done over the years. And my idea was, what could I run this to generate new kind of similar sounding blog post text? And so basically I made a new directory in my downloads called GPT2, and I basically aggregated all my blog tests, or a bunch of them, into a text file. So here is the text file that I created, and I just copy and pasted my blog post text. So each one of these is a line, and there's no special format here. It's just a text file with each line being its own sentence or paragraph or whatever. And so this training, I've created a list here. It only has like 350 lines of text in it. So, of course, the more text you have, the better it would probably be. But, even out of this, let's see if we could get some results. And so what I did is I modified the script. So what I did is I created a new directory in my downloads. And so basically I created a new directory called GPT2 test. And in there I have the blog test file, txt file, and then I just copied over that GPT2 test file that generated the Shakespeare text. And so now that we have that, we need to go in and modify it to make it work with the new text file that I generated. And so if you look at that file, looks like this. And so what I did is it still downloads the model because I put in a new directory, so it's going to download the model again, so that's okay. And then I just basically got rid of the part that has all this downloading the Shakespeare file, and I just put the text file name that we want to use instead. So I called my blogs.text, and then this is the same thing, and then I set the iterations to 500. So then we ran it for 500 steps, which is, the first time we ran it just as the test was for 100, and the results looked okay. The demo had it for 1,000 iterations, then that would have taken a long time. So I ran it for 500, and this took a very long time on this computer. So this computer had like it's 4-core processors, and it took 3 or 4 hours to run through 500 iterations. So it's a very long process. Again, as you mentioned, if you're just using your CPU and not a GPU to train this stuff. But you only have to train it once, and then you have a model that you can reuse. So if it takes 12 hours to run on your computer, that's okay, right? Because then you have the model, and you can reuse it. So we can look at the results of this one, and basically this is the results. So I trained it on my blog. There's kind of more technical kind of stuff in it, but it creates these kind of sentences that are kind of make sense in this context that they are kind of framed out of, but it's kind of like gibberish text in a way, but it sounds real, right? Like you couldn't just be like, boom, create a new blog post and publish that, right? Because it's aggregating all these different ideas into a text kind of output, but these ideas aren't cohesive across all the text, right? It's just generating text that uses the right words, and it's basically just like starting with a word and then figuring out which word should go next, right? It's predictive text. So it makes sense like in the context of the line, but it doesn't make sense in the context of the entire document if you wanted to generate an entire document. Um, but it kind of makes sense. So like here's one, like it will add new CSV file at the end of each line saying something about the thing that it is adding. Like, okay, like that makes sense, I guess, if you had it in a certain context. We can use this workflow to add items and properties and make them more specific. Right. So I never said that. I never wrote that text. That sentence, but it generated it, and it like kind of fits into the style of my kind of straightforward kind of technical writing style of this blog post. So yeah, so this is kind of like pretty good results. I'd be interested just to run this for 1,000 iterations and see if there's any difference to it. But that's if you want to spend more time doing that to test, to play around with the different iteration levels. All right, so this is good, but the thing is this is just outputting to the screen, right? We want to do something with it. And so, I did a LSH in this directory, and you can see that these are the files that are in the directory. So this is my blog text file. This is the model, where the model is stored. It creates this checkpoint file or a directory. This is the script that we wrote to do this generation. And then this is more data that it downloaded, right? So you probably want to make, if you're going to do a new project, like train it on something else, you probably want to make another directory and put your script in there, because it's going to create a new model. And if I ran this back in the downloads directory where the other Shakespeare one was, it would overwrite that model, and I would lose that model. So we want to make sure that you have it separated in its own directory, and then it's going to store it in there. So if we looked in that checkpoint directory, there's a subdirectory called run, and then here's all the models that it generated from. All right, so this is fine, but our problem, like I said earlier, is that we want to actually do something with this text and not just print it out to the screen. And so if we go back to the library page, it has some more examples of what you can do. All right, so it says if you want to generate, like I said, the model is stored in this checkpoint run directory, so it just looks in there every time it wants to generate using a generation from a set model that exists already. So it's expecting it to be there if you're going to generate without training. It says if you want to load a module from that folder and generate text from it, you just basically run this script instead. So you basically just import it, start the session looks at the model, it loads the model, and then you generate text. So let's just see if this works and see how long it takes to actually try that. So I'm going to make a new directory here, or make a new Python file. And we're going to call it, save it in that directory and call it GPT2 gen.py. Alright, and I'm going to save that. So I'm just copy and pasting that example. Alright, so let's run this and see if it actually does what we think it would do. Alright, so there it is, GPT2 gen. So let's run that, Python 3. So hopefully, right, this is not going to take hours to run, right? Because the hours part was to train this model, and then it stored the results of that training in a file. And so now it's saying it's loading this checkpoint file, and it should generate the new text. Alright, so it ran and executed, and it just generated more text to the screen, but we just want to make sure that the model worked. And so that wasn't instantaneous. It took, a couple minutes to load the model and then actually run. But if we look at this output, some repetitive stuff here. Yeah, so it's kind of interesting to read this. It's like very, I could see myself writing these sentences. But the next thing we want to do is, this is still just outputting it to the screen, right? So we know it works, but it's generating for the model, so it works. But we actually want to do something with it, right? Programmatically, we don't just want to print it. So if we look back at the web page, it has more information. So it says you can generate a save file for later use for an API bot by using the return as list parameters. So you say return as list, and so this will basically return the data, this text, as a list of text, as opposed to just dumping it out to the screen, printing to the screen. So what you could do, right, is instead of just printing it like they're doing here, you could write it out to JSON, right? And so let's try doing that as a script. So we will. So instead of just generating it like this, you can generate and say return as list. And so you could say, okay, we're going to call this text equals return as list. And so this will return this data as a list, and then we'll import the JSON module. And we'll say json.dump, and we're going to say with open new text .txt or .json, sorry, as write as output. And we're going to say json.dump. We're going to dump the text that it generated as a list, and we're going to store that in the output, and we're going to indent it too. Alright, so it's going to, instead of just printing it to the screen, now it's going to actually write it as a JSON file that we can do something with later. So let's give it a shot again. Alright, so that finished running. Again, it took a few minutes to do. And we didn't get any output to the screen this time because it's supposed to be writing to a JSON file. So if we looked in the directory, we should see a file called newtext.json, and it's 4.4 kilobytes. So if we open that file, we would see our text as a list, as JSON list. Right, so here's a list, and each each sentence or fragment of text would be a new hopefully a new list. Oh, it's interesting. So it returned it as a big list, but it's all kind of one item in that list, which is strange. So this is basically generating like an entire document, and this thing has a number of sentences and stuff per document. So let's look at the instructions some more. Or there's a bunch of arguments you can pass. So here's some information about those. And so basically you can play around with these things, but you can say batch size. So batch size might generate more text. So let's see if we can do this. And this also has a lot of kind of detailed information about how this kind of library works. And again, it's mostly focused to work on GPUs, so basically graphics cards. So you might not have, it might be a lot of kind of fine tuning to get it working with just your CPU. But let's try to change this code so that we add a batch size parameter. So we're going to say return as list true, and then we're going to say batch size equals, let's say 10, and see what that does. And everything else the same. All right, so I'm going to run it. All right, so it gave an error. It says assertion and sample divided batch size equals 0. All right, so let's try their example here, where they have batch size of 5 and end sample size of 5. So let's see that what that does. All right, so I'm going to run this and we'll see what the results are. All right, so finish running. It took about 5 times as longer as just running with no end sample size. But let's look at the results here. So this is the same file, just reloads. So now you can see that this list, right, this JSON file now has 5 entries in it. And so basically created 5 new documents, right? And so you could do a lot of different things based on this. If you were just interested at a per line document, you could split this text up by line, right? So for example, if we wanted to make a new file and call this process results.py, and so we'd import JSON, we load that JSON. So we're going to open the files called newtext.json, and then we could say for line in data print line, right? Let's try running it. So print out each of the items in the list, right? So there's 5 things there. So what you could do is you could say for each, split the sentences by line. So you'd say, line.split and then split on the new line character. And then you could say for S in sentences, print S, and then we're going to print a little line there. So let's give this a try and see what it says. Right, and so now you have basically a bunch of fragments that you could do anything what you want with, right? You could tweet these out, you could generate some other stuff with it. You now have more of a granular representation of each generative piece of text. All right, so let's review a little bit about what we did to get this working, and it was a little bit of a kind of difficult twisting road because we ran into some problems. So there was 2 kind of different variables, right? So we're using this GPT2 simple module to work with the GPT2 model, but that requires TensorFlow, which is a more generalized machine learning framework, and that requires Python. And so the problem was that this GPT-2 simple wanted to use TensorFlow version 1.5, and then that requires using a lower version of Python because newer versions of Python expect you to use newer versions of TensorFlow. So we kind of got caught in this little dependency kind of feedback loop. So basically to get around that, we wanted to install something that let us run different versions of Python in parallel whenever we wanted to. And so basically we did that by first installing Homebrew. So Homebrew is just a way of installing software on Mac. It's a very easy way of installing stuff. So it just makes everything just work properly. So we make sure Homebrew is installed. Then we installed this PyEnv software, which basically is a way to switch between Python versions on the fly. So we did brew install PyEnv, PyEnv. So then once that's installed, we can install whatever version of Python we want. So we install the lower version. So we did pyenv install 3.5.10. So that installs Python version 3.5. And so then we closed our terminal, reopened it so that it was, refreshed. And then we basically said, okay, let's use Python 3.5.10 as our version of Python on the system. And so that basically makes 3.5.10 the version being used on your system. And so you can test that by saying Python 3 hyphen uppercase V, and then that will say what version of Python is being used. So now that we're on this new version of Python, we can actually, it's a different install for modules and stuff like that. So then we can do pip3 install GPT2 simple, and then we can do pip3 install TensorFlow and pin it to that version that it wants to use, which is 1.15. So that all worked, and then we can go off and do our script. There was a little bit of a modification we did to the test script, or the kind of example script, because it uses the f strings, and we don't have f strings in 3.5 version, so we had to remove that f string. But that was like a very minor thing, and then it worked, right? So we can play around with the scripts, and there's a lot of variables in this software, right, to play around with the sample size and things like temperature and number of iterations. And unfortunately, it takes a very long time to train if you don't have a very powerful, computer with a very powerful GPU processor. So it is a little bit of investment, but then you have the model, and once it's in the right place, you can do stuff like generating lists of text that we went through and showed how to play around with. So it's done. So the thing you should be aware of now, though, is that now you're basically running Python 3.5 whenever you type Python 3. And so you might want to switch back to the newer version, right? Because you want to use the newest version of Python usually. So then you just say, okay, install the latest version of Python with pyenv. So pyenv install 3. Whatever, 3.9 point whatever, and then use that one instead of 3.5. So you'd like switch back to the newest version of Python, and then you'd use that. And then if you wanted to do more of this, you could switch back to 3.5 if you wanted to do more on the TensorFlow GPT2 simple. So that was quite a little adventure there. So thanks for watching, and I will talk to you later. Bye.